work. But we managed to get it going. Gentlemen, if you don't mind, I'm going to leave that to you. You probably will want it better than I. So first off, I'd like to introduce myself. My name is Steve Worth. I'm with DNC Corporation, and my two co-conspirators here, Henrique and Guerra, and Arthur Guerra with the Eldorado Research Institute, another group that we work with. And originally I was coming here to make a case and a pitch to the whole group about what should be done around hierarchical metadata, but as I listened to the conversation and thought a little bit about stuff that we learned at BioIT World last month in Boston, I want to switch the gear just a little bit and actually break this up into three pieces. The first of these is that I probably should kind of give this group a bit of a viewpoint about what we got, why we got involved in iRODS, and what we tend to care about. Two, to update you on some work that we started last year and reported on in this group that's basically ready to go. And then I'd like to do a little bit of talking about how we see hierarchical metadata possibly evolving. So hopefully this will be fun for at least 15 minutes, and then we'll see after that. So I got involved in this a couple of years ago, not because I care about life sciences and genomics, though that's where I got involved in. I've actually have played around with metadata a few times in my career. I have a couple of failed attempts to build worldwide global namespaces using centralized metadata systems from years ago that we won't go into. But they taught me a lot about what it takes to do some of this stuff at scale. We got involved, though, in working with some of our customers who are involved in life sciences, and I know a lot of you are. And I got this really quick education I want to summarize for those who are not from this field, which is, if you're doing genomics research, your goal is to find the needle in the haystack. Or as a researcher once told me, my real goal was finding this particular aluminum needle in a whole haystack full of steel needles, which I thought was an interesting way of phrasing it. And what we find from working with these folks is the price of doing a genome sequence goes down with data. I think you made a very good point with your talk yesterday about how fast and how much data is generated out of this. But we're seeing that the amount of information is just going up fantastically. There are a number of organizations throughout the world involved in doing genomics research that are attempting to probably sequence somewhere on the order of 100 to 200,000 humans across different countries in the world. And you take a look at that, they talk about it from the standpoint of how do I get to 5%? Well, I got to playing around with math one night and realized 5% of all the population of the US and the European Union represents about 71 million people at 100 gigabytes per genome, and it's actually more than that. You're now all of a sudden looking at around 20 exabytes of data. And at Amazon glacial storage cost, nice little number there of a chunk change. I'm sure all of us have it sitting around. In fact, I got tickled. EMC for years has pushed the fact that we do these kind of analysis ourselves. And we think that there will be roughly somewhere between 44 and 50 exabytes of data in the world by 2020. That's a little over 3 years from now. And you do the math on that, and you all of a sudden discover just to hold the first copy of all that data on spinning Rust will be $45 trillion. Amazing. Yay. So, yeah, yay. And you have to pardon me. I'm going to show you a little bit about why I'm considered a heretic in some spaces. But I and others that are involved in this space, we're out trying to teach customers how to build these nice, beautiful data lakes, and we show pictures that look exactly like this, and we talk about how wonderful they're going to be. But when you look at the reality, all we're doing is we're shoving all this data into these data lakes, and they're very quickly starting to look like this. In fact, I got tickled. I was talking to the head of a hospital just a few weeks ago. Actually, it'd be more like he was kind of yelling at me. But his comment was, I've grown from 3 to 30 petabytes of data in 2 years. I support 120 researchers and companies. I have no clue what's in here. And I looked at him and said, and that's my problem? No, I didn't do that, but I wanted to. But as I've gone through this, one of the things that I've been taught is that, as computer science people, we tend to think about categorizing this information using automated tools and so forth, if you will, postfix on file names and things of this nature. But one of the things I got taught about last year, about this time actually, was that it's not nearly enough. We think of data and data ontologies. But I've seen now about 4 examples in just the last year of where, if you look at something like the good old simple mullock shell, you'll find right off here at the coast of North Carolina. You say, wow, well, there's a lot of variation there. And yet the very paper that I took this out of talks about the fact that the researcher involved believes that both the distances and the coloring on the shells change through the lifetime of the shell. And you start thinking about trying to put that into an ontology system, and you begin to quickly realize that it's not just machine metadata, it's not even simple metadata that you add. There's going to be this kind of time, if you will, context basis that's going to have to go into some metadata that we're all going to struggle with. And in fact, I've seen this year myself just how bad this struggle and how quickly it's coming about, because I'm now talking to people who are telling me about their coping behaviors, and coping behaviors are really astounding, right? I know I have talked to real life customers who buy our stuff who tell me that they're burning their data. I don't know what it is, don't know where it came from, I'm not going to spend the money on it, boom, gone, getting rid of it. There are another group that have actually, because data, they talk now about data gravity. In fact, I had one person tell me about their data has gotten to be so massive, they call it the black hole. And it's the black hole because they can't afford to move the data around anymore. They can't even afford to make a copy, so they're living with one and taking the risk. And then the last one, I saw this actually a lot at BioIT World this last month, is that now people are starting to say, oh, I have this beautiful data archive. You want access to it? Send $5 to Reagan Moore. You can.
That's why it's retired.
Exactly.
How many trillion was that again?
But you know, the thing is that the cost of keeping the information just beyond the bits that are going on storage is the reality is that the cost of the networking is almost now 5 times the cost of the storage itself. And so people are beginning to make very careful choices about who they give access to, how many copies they make, and so forth. It's not bad at this point, but I've seen enough examples of it to where I know it's happening. So as we thought about this, and this is why we got involved with the group here, it's going to become obvious if everybody's going to do these coping behaviors, what are they going to do? Well, they're going to quit sharing the data in terms of giving you a copy all the time. What they're going to do is give you something that's a proxy and say, okay, evaluate the proxy card, tell me if the data is what you want, and then let's discuss how you're going to pay me back. And so all of a sudden, all this metadata you guys love become really important. And while it's not that we don't care about data movement, data management, all that kind of stuff, this to us is the thrill of what's going on here, why we've been participating. So I started trying to get involved in going out and talking to everybody I could about iRODS and so forth, just like all of you do here, Dave, I know you do, and others. And I quickly ran into this problem with our folks. Yeah. Most of our users don't know what a programming language is, and they've never written a Unix command in their life. This isn't going to work. So we decided the only thing that we could do that would make sense in the short term at least is to try and figure out how to make it easier for commercial customers to possibly adopt iRODS. And yes, I know I'm about to show you what's got to be, I think, the 6th or the 5th of 6 user interface designs you're going to see in these 2 days. But our concept behind this has been largely, and I don't mean this to be offensive, I'm not trying to pitch this to you all. You're already converts. You believe. You signed on for the religion. Okay, we're more interested in people who have looked at iRODS and said, nah, it's too complicated. We're not interested. And trying to figure out how to bring more of those into the fold. So what we're going to show you is a little bit of UI work that we've done that attempts to simplify working with iRODS, changing out all the nice commands here for more graphically oriented screens. Try to make it easier to deal with administration. This actually is one of the things all of the people we talk to complain about to us. Trying to work at making it easier to do automated metadata extraction, and nothing magical here. We've just provided some rules to help go along with some of the genomic data file types. We actually have implemented a small system that does metadata templating. I'm sure it's not nearly as good as what Cesar has in the back of his mind, or Mike, I'm sure you've got even more ideas than I will on this, but
I'm just going to interrupt here and say I see no reason why we can't look at consolidating efforts.
absolutely. So we'll get to that as time goes by. And then, of course, trying to do something to help make it easier to search after you create all this mess that I just talked about. So, from our point of view, what we're trying to do is to make this into a simple tool, and the guys behind me here are going to show you some of this in just a few moments, but I want to make sure you understand what it is we did. First off is the architecture behind this. It very simply is a simple web application that can live either on one of your resource servers or your iCAD or some other server. We do make use of a small database that we have to have because there's some information about your user state and so forth that we kept. We thought about shoving it back in the iCAD, but finally decided at the end that that possibly is putting too much load for something that ought to ride alongside of iRODS versus in iRODS. It would not be hard to change, but we decided against it. And we use little processes that we call remote monitoring daemons that essentially will sit on the iCAD or resource servers and essentially act as dumb, if you will, dumb agents, where when we go to our dashboard page and we want to try to find out whether the server is actually alive or dead, we query this thing and it can report back based upon hidden commands certain types of information. We don't pass any control information or administrative information, just status, like how many CPUs are involved, what's the disk layout, that kind of stuff. So, fairly simple. The piece that I'm happy to announce is after, I don't know, I guess we've been 9-10 months getting it done and 3 months fighting through EMC legal. It's finally out. Right now, and I don't know, this doesn't read very well, but it's on a private repository that I had that I published this morning. We're actually going to be moving it to EMC's open source site, EMC Code, hopefully within the next few days, hopefully under a week, to be honest. But it's there, it's available. I do not yet have a way that is corporate approved for me to distribute the Docker image we have and the pre-built RPM and dev files, but our build instructions are so dumb even I can follow them. And they do work, they're all well tested, so please feel free to kick the tires. Now, Mike, going back to your point, what we're hoping to do with this is not to get into some kind of competition about what UIs are best. We'd like people to use this. If you like it, get involved in the community. Maybe we look at trying to merge some of the efforts that are behind this. I don't really know. We've just been concentrating on getting to this point right now. Now, I don't mind admitting, in our minds, because of the people that we talk to and the fact that I want to get more commercial customers using iRODS, there are some things that we're wanting to look at doing. One of these is the area of metadata validation. And some few things that we had to leave behind because of time constraints to get here. And we may work on these, and then again, if the community will get involved with this, we'll take input from that and kind of work together on this. One thing we do want to do in our little demo, though, the Red 1 code doesn't support data validation. We've been playing with this since we got back from BioIT World, but I'd like to at least explain the concepts that we walked away with from that meeting that we're trying to put together. We learned from the folks that we talked to who are in the, what I'll call the personalized medicine and commercial genome management space, that they have two desires around data validation. The first of these is a technique that we call lazy validation that we've got working enough to show you today. And the concept is that if I go and create a metadata tag, I can define as in creating the tag what type of data it is and what its parameters are going to be. What we're doing right now is basically taking that information into the UI and adding it as a hidden metadata tag that we filter out, so it's actually in the iCAD. But we can then, through the UI, enforce the behavior of that metadata tag until you delete it. In other words, if you go to edit a value, you're going to have to stay within the limits. The piece that we want to get done, and Mike, I think you were the one, somebody in here, almost Mike or somebody else talked about it, that we want to use this first because it implements the other, is essentially going to be a lockdown vocabulary.
Yeah.
You define it through the UI either as some kind of a schema upload, or you can manually edit it and then lock the whole system down. And you will be forced to go through and pick your attributes out of that list. Though we've already figured out, because of who we talk to, there are 4 models of it, right? None, totally locked down, system set lockdown, and then users can define their own or wide open. So we'll end up with all of those. Don't know for sure when we'll be done. I have to admit, this is a part-time project part for us. We've been at it for a couple of weeks. What do you guys think? maybe month and a half more, we'll be done with it. But at any rate, they want to show you this, and so I'm going to step aside and just kind of show you here how the validation works. You define it somewhat like this. You put your metadata in, you can actually look at the details, and we'll show you, you know, what kind of type it has to be, so to speak. But I'm going to let them take the floor. Is it big enough?
10 minutes.
Oh, we're fine. So I'm going to let you guys take the floor for a couple of minutes and take over and show a little bit of how this works.
Yeah, now it's time to have some fun, right? So Henrique and I are going to show you some of the core functionalities that MetaLnx has. So if we log into the system, if Henrique can log into the system, the dashboard page is the first page admins can actually see. In that page, you can now check. Oh, okay. Yeah, this is so you can now check all the system health status and see if your entire grid is fine. Okay, oh, my grid is not normal, something has happened. You can also check the resource map and check all the resource tree you have. And you can also check all the resource, the iRODS servers available in the grid. So you can even get some more information from the server. And we now provide you some CPU information, memory information, partitional stuff, and you can even get access to some of the iRODS server logs. Not all of it, but some of it. Now going straight to the user management page. That's where you were able to see all the existing users in the system. So now you can create new users, modify existing users, and remove users from the grid. The groups management page follows the same idea. That's where you can see all the groups you have in the system. You can attach new users to the group, remove some users from the group if you want to, or even delete the group. Oh, I don't want this group anymore. That's pretty much what admins can do with MetaLnx. So jumping into the collections page, that's one of the most important pages we have in MetaLnx. That's because you are going to be able to see your files. That's where your files live. So here, by clicking on collections, MetaLnx will bring you to your home collection first, and then you can just navigate through the file system. So if we check the files, we already have some files available here. And if we go under permissions, there you can even give somebody else permissions to your file. You can give read permissions, write permissions, or ownership permissions to a group or to a user. You can either remove permissions from them by setting it to none in case you don't want somebody to have access to it anymore. Now going back to the file, one feature MetaLnx also has is the ability of checking the metadata around your file. So that's where you can see all the AVU tags attached to this file, and all this stuff is coming from the catalog. And you can also add a new piece of metadata if you want to, by just typing whatever AVU tag you want to add to the file. And that is going to be available, that's going to the catalog in the grid. So you try to just add a piece of metadata that already exists. So iRODS will complain about it. That's why we get this response. But let's say now I don't want to just add a single piece of metadata to a single file. I want to add like several pieces of metadata to several files all at once. How do I do that? That's when we came up with the idea of templates. So you can basically say, oh, now I have this predefined set of metadata that I want to be able to apply against a set of files. So a template basically is a set of metadata that's already defined. And going back to the collections page, you can select the files you want to apply this template against and say, okay, now I want to apply this metadata. I'm going to select the template. I'm going to hit next. And this metadata is actually being pulled from the template. And now they're going to be applied against the set of files you just picked. And this stuff is now going straight to the catalog. And it's going to be available in the entire grid, right? Good. Now I have my files, I have the templates, I can add metadata, I can modify them, I can delete them. How do I search for it? How do I find my files? So that's when we create our search engine. So you can basically say, I want to look for all files that has an attribute that are equals to something, or it's not equals to something, or maybe contains or does not contains a value that I'm setting. So the way it works is, if I type something in the search criteria, and after you hit search, MetaLnx is going to the catalog and say, okay, give me all the files that actually match this search I just defined. And we're going to order the files based on the number of matches that you define in your search criteria. As you can see here, the first file has 2 matches, and the second one has only 1 match. That's because the first file has both attributes and values, and the second one has only 1. So that's something we already have implemented. So now let's talk about what Steve just defined, which is how do we define what is the type of my metadata? Because right now, iRODS only has strings as your metadata types. So as you guys probably noticed here before, we have this select box saying type. And what I'm going to say is, I have the type, so how do I tell iRODS, okay, I want this attribute named age to be an integer? Because that's much more useful than a string. So after I define it as an integer, how iRODS MetaLnx will not complain about it if you type something different than an integer, because that's supposed to be an integer, not a string anymore. And right now we're supporting floats, lists, dates, booleans, and range of numbers of different types. So that's pretty much what we have implemented right now. It's not 100% working, but you guys can still have an idea of how it's going to behave. And this feature will also be available through the template. So as soon as you apply a template against a set of files, you can define all the metadata types that those metadata should be. So that's pretty much what I have for all of you guys. I hope you liked it. As Steve said, we are now open source. We're available on GitHub, and we're looking forward to hear a lot from you. And you can just have an idea if you guys want do some contribution. You're very welcome. Thank you very much. I appreciate it.
Carol, can I steal 2 minutes?
I guess.
Well, one of the reasons I wanted to do is to finish what the topic really was when we first put this together, which was to talk about why hierarchical metadata we believe is going to become interesting, because I've continued to work with folks in the genomics research space. Groups such as the Global Alliance for Genome and Health and others, we're beginning to see that they want to define hierarchies for metadata around both plant, human, and other genomes. And their actual working groups are pursuing through this, as I'm sure many of you in the room who are in the space know. There are even groups like the Gene Ontology Consortium that are now trying to figure out how to build overlapping and mapping databases of all these hierarchical metadata types. But I also got tickled that the GA4GH, after a year and a half's worth of work, just about 6 months ago, decided that this was such a hard problem that they built a framework, high-level framework, sound familiar? And have delegated the task of dealing with the ontologies to lower-level things. But the point is, I do believe it's going to become valuable. And as we were going through this, we also realized, well, okay, yeah, I understand we have hierarchical databases, we should have hierarchical metadata. But what really caught me off guard, just very recently, about 8, 9 weeks ago, right before BioIT World, was that ontologies we think of, you define it, you add to them a little bit, but all of a sudden, in this day and age, because I've personally never seen it before, maybe the rest of you have, is that ontologies now want to become adaptive. And I found by accident what's going on in the library sciences space. Again, all of you here at SILS already know all this, but I was taken aback by it. The Dewey Decimal System that's been in existence for roughly, I believe it is 300 years if you're American, European, and a century if you're based from India. But the fact is that it's going away, and it'll be gone in under 10 years. It's slowly being replaced by new kinds of ontologies that are much more adapted to the kinds of material and books related to computer science and other forms of research information that are coming out, particularly, believe it or not, fiction, that the Dewey Decimal System cannot handle. And then I got into listening to what library science people were telling me about this, because I sat on a couple of boards related to this stuff, and I discovered that they have realized that amongst the college students, people are now browsing metadata. Now, we don't think about it. We know them as things such as gene browsers and, suggestions lists from Amazon and so forth, but college students do this naturally. I mean, they search Twitter like we would have searched through the chapter list of a book when we were growing up, so to speak. And in fact, the way people are searching for metadata is changing absolutely in real time around us. These are just some examples that I found recently of systems that are collecting both data and using metadata to tag how they're going or how they're used. And then they're building these new kind of graphical browsing tools right on top of it. So one of the things that we're likely ourselves to go into as a bit of a pet project is trying to figure out how to do something about applying hierarchical metadata structure around iRODS, and then see if we can figure out how to tie it into some of these kind of new age mapping tools. One of the things that we would love to see done is what I will call adaptive metadata browsing, for probably lack of a better term, but the idea is to essentially take the iRODS model that there is today and come up with a way to build on-demand ontology maps that would allow you to both take an existing ontology and map it to another one. Like, it's very similar to what you're doing with virtual tags right now. But then likewise allow people to define their own virtual mapping capabilities so that they can take existing ontologies as they exist and actually view them and browse through them hierarchically in ways that they want. So I think that was my 2 minutes. I'll stop at this point. Yes, Ray?
You should look at high technology, healthy interdisciplinary vocabulary in
Yep.
here.
Yeah, we're trying to learn that right now. And I want to be careful. I'm resisting the urge to say that this is just an indexing to do problem. Because something tells me when you start adding time varying constraints to it, it's not. But we'll see. If there are any other questions, can we take one more or anything, or we're done? I think we're done then. Thank you all very much. We appreciate it.